Good morning friends. Today we are discussing our new topic, types of chemical reaction. In this topic we will discuss about different types of chemical reactions. In that our first chemical reaction was combination reaction. What is combination reaction? A reaction in which single product is formed from two or more reactants is known as a combination reaction. Means when we take two reactants, more than two reactants, when we will react that reactants, okay, then the product we will gain, that is only a single product. Let's take us some example that you will understand. Now here CaO means quicklime, and another name was calcium oxide, and H2O, that is water. Now here we will take two reactants, one is calcium oxide, second is water. When we react these two elements, these two reactants, then we will get CaOH twice, that is called slag lime, and another name was calcium hydroxide. OH means hydroxide, and heat will released in this reaction. Heat will released, only we will CaOH will get. Okay, now here calcium oxide we will taken in a solid form and water in liquid form. Understand? Now the second example, burning of coal. In that also we are taking two reactants and the product we will gain, that is only a single product. Here also carbon react with oxygen, and carbon is in a form of solid and oxygen is in a form of gas. When carbon in solid form and oxygen in gaseous form will react, the product we will gain, that is CO2, and it is in a form of gaseous state. And the third example, magnesium ribbon. We will already discuss in examples of in our first part and second part, magnesium ribbon. When magnesium ribbon is in a solid state and react with oxygen in gaseous state, and we will provide heat from outside, then the product we will get, that is magnesium oxide, MgO. Now here formation of water, it is also an example of combination reaction. Why? Because in that also H2, that is hydrogen, in a gaseous state and oxygen is also in a gaseous state. When these two gaseous state, oxygen and hydrogen, react, the product we will get, that is H2O, and that is water, and it is in a liquid state. These are the four examples of combination reaction. So you will better understand what is combination reaction. A combination reaction in which two or more reactants will combine to give us a single product is known as combination reaction. Here we will take four examples. We will discuss another topic. Now exothermic reaction. What is exothermic reaction? It is also joined with that. Okay, exothermic reaction are reaction in which heat as well as energy is released. What is exothermic reaction? A reaction in which heat as well as heat or energy will released when chemical reaction was going on. This is our example of exothermic reaction. Example number 1. Here calcium oxide and water was reacting, and CaOH, calcium hydroxide, we will get, but in that heat will released. When in any chemical equation, if in a product heat will released, then it is called exothermic reaction. So it is an exothermic reaction. Understand? Okay, take another example. Respiration is also a exothermic reaction. We all know what is respiration. Exhale and inhale. What we are breathing now? Exhale and inhale. When we are exhale or inhale, inhale, we will get oxygen, we will take oxygen in our lungs. So how it will react? Whatever we are eating food, they goes in our body in a form of glucose and they store in a cell, right? When we will take oxygen, it will also go at cell, and glucose and oxygen will react and it give us product. What is that product? CO2, carbon dioxide. When we exhale, we give carbon dioxide. Water, our body evaporate water because to maintain our temperature cool. And energy. And if we didn't eat, we didn't get energy, right? And whatever we are eating, that is convert into a glucose, and glucose and oxygen will react and it give us energy to do work. Now understand what is exothermic reaction. It is a reaction in which heat or energy will be released. Now another example, endothermic reaction. It is also a reaction. In that reaction, we are not really releasing heat or energy. In that reaction, we are absorbing heat and energy. Okay, see some example. Now these three examples are of endothermic reaction. See, in burning of coal, when we burn the coal, if we will give him heat, so in this reaction heat will be absorbed by the reactants, so they give us product CO2. Now magnesium ribbon. In our magnesium ribbon, we are also providing heat from external, means in that also reactants will gain heat and absorb the heat. Formation of water, in that also heat and energy will be absorbed. So it is an example of endothermic reaction. So understand, if in any chemical aqueous reaction, if energy and heat will be absorbed, it is called endothermic reaction. If energy and heat will be released, then it is called exothermic reaction. So it is clear what is combination reaction, what is exothermic reaction, and what is endothermic reaction. So our second reaction is decomposition reaction. What is meant by decomposition? Here decomposition means by separation. In this reaction, we will convert a single reactant into simpler product. Means in combination reaction, there are two or more than two reactants combine and make a single product. But here it was reverse. Here a single reactant will break down into simpler product, two and more than two elements. Now here some example. Okay, 2 FeSO4. FeSO4 means ferrous sulfate. Ferrous sulfate. Fe means iron. It is also called as iron sulfate also. Okay, when we provide heat to this compound, it will break down into three simpler product. What was that? Fe2O3, that is ferric oxide. Yeah, we will call iron oxide. It is in a solid form. Second product SO2, it is sulfur dioxide, and third product is SO3, means sulfur trioxide. Understand? In decomposition reaction, one reactant will break down into simpler product. Now here it is second example. Here Pb means plumbic, and it is also called as lead. Lead nitrate. Lead nitrate, when will provide us heat, then it will also broke down into simpler product. And what was that simpler product? PbO, means lead oxide. Yeah, we will call it plumbic oxide also. NO2, nitrogen dioxide, and O2, oxygen. These three simpler product we will get when we will heat a compound PbNO3 twice. Third example is CaCO3. It is also in a solid form. if we will provide a heat to that compound, it will also broke down into two simpler product, that is CaO, that is calcium oxide, and another name was calcium oxide was quicklime, and it was used in cement industry and at our home. When we made our house and we are going to plaster the wall, we are seeing that in the cement we are adding quicklime, means calcium oxide, that we call chuna. We will add chuna in cement, and that is quicklime, and the Hindi name of quicklime is chuna. And the other product we will get CO2, that is carbon dioxide, that was released. Now fourth example is AgCl, means silver chloride. When silver chloride, in that reaction we are not giving him a heat, they get sunlight. When it gets sunlight, the AgCl convert into silver gray, means silver color was convert into gray color, and Cl2 will separated with AgCl. What we will see here, in all the examples we will see that compound will break down into simpler products, means here FeO3 will separated and SO2 separated and SO3 also separated. In this example what you see, Ag and Cl both are separated, and decomposition means separation, that's why its reaction was called that decomposition reaction. And the last example is AgBr, means silver bromide. It is also react when sunlight, it will gain sunlight. When it is also separated, Ag and Br also separated. Br2, it was used in black and white photography. Now we will see 5 examples, and decomposition reactions are 3 types of, in that 3 type of reactions also have. What was that? When we separated compound by heat, it is called thermal decomposition. If when we separated compound by sunlight, by giving sunlight, it is called photochemical decomposition. And an example is not given here. A compound when separated by chemical, it is called when a compound will separated by the electric current, then it is called electrolysis decomposition. So let me see all the 3 types and their examples also. Now first, thermal decomposition. What is thermal decomposition? A thermal decomposition in which compounds break down into simpler substance by heat, means when a compound separated by giving, when a compound separated by giving heat into simpler substance, that is called thermal decomposition. Here it is an example, CaCO3. We will see it in a decomposition reaction, this example. In that calcium carbonate will separated and give us products CaO and CO2. Second, photochemical decomposition. What is photochemical decomposition? In which sunlight is used for decomposition of a compound. In this reaction, we are using sunlight to decompose the compound. See here example, AgCl. When we give a sunlight, when we use sunlight to separate, to decompose this, what we get? Ag plus Cl2. And our third reaction is electrolysis. The name hidden in this, what was we are using, the name also hidden here. Electro means electric current. So we are using electric current to break down the compound into simpler product. See here, electrolysis in which a compound is broken down into simpler substance by passing electric current through it. If we pass the electric current through a compound, that we are taken as a reactant, it gives us product breaks down the compound into simpler substance. So we are using electric current, that's why it is called electrolysis. And the example, water. If we want to break down the molecules of water, if we want to separate hydrogen and oxygen, we are using electrolysis process. In this process we take a beaker, and in that beaker we put water, and when electric current pass through the water, it will break down the molecules of water. It will separate H2 and O2, that we get us as a product. So these are the three examples of decomposition reaction and three types or kinds of decomposition reaction. Our third type of reaction was displacement reaction. It will completely different from first two reaction. What was the first two reactions? Combination reaction and decomposition reaction. Okay. Now our third is displacement reaction. Displacement reaction is a chemical reaction in which one element replaces another element in a compound. Okay. Let's see some example, then you better understand. Now here I will take iron in a solid form and a compound. It is a metal, okay, and one compound, copper sulfate. When metal react with copper sulfate, means iron react with copper sulfate, then copper will be displaced by the iron. So see here, what was that? Copper sulfate. Now copper will be replaced by iron. Now what was the new product? Iron sulfate, and copper will separated by their compound. See another example. Here I will take on here zinc. Zinc will react with copper sulfate. Again we will take copper sulfate. In here also zinc replaced copper, and copper will separated by their compound, and what will we get product? Zinc sulfate, and copper will be separated. Here lead, Pb means lead, and it is scientific name was plumbic. Here lead will react with copper chloride. Here lead also replace copper by their compound, and it makes lead chloride, and again copper will be separated. Why it was happening? Why we are not writing here like this? Copper plus FeSO4, and it give us CuSO4 plus Fe. Same na? Here I will take iron separated, and in a compound of I will take here compounds copper sulfate, and here copper will be separated, and I will take here iron sulfate. So it gave us same reaction, right? Copper sulfate plus iron will be separated from their respective compound. No, it was wrong. Why it was wrong? Because a metal will replace the another metal by their reactivity. The most reactive element always replace the least reactive element, and here in this case iron is more reactive than copper, and here copper is least reactive than iron. So it is not happen that iron copper will replace iron. It is not happening. Why? Because copper is less reactive than iron, but in this case iron is more reactive than copper. That's why iron will replace copper to their respective compound. Here also zinc is more reactive than copper, so that it will also replace zinc to their respective compound. In this case lead also more reactive than copper. and we will see the reactivity series. Then it is clearly you will see which element replace the another element. Here copper is in a last 3 number, and iron, where is iron? Here. If we go down to up, means the reactive series is more reactive when it goes down to up, means upper elements are more reactive than lower element. Understand? Means the least reactive element was gold, then silver, then copper, then hydrogen. Okay, if we will go down to up, the reactivity of that element was increasing. Okay, means the most reactive element was potassium. Okay, and the least reactive element was gold. So what we have taken here, all the compounds we will take here copper, right, and we will take a separate metal iron, zinc, lead. So we will see in the reactive series कि all the elements that we are taken here, it is more reactive than copper or not. See here, copper and all the element iron, lead, zinc, these all the elements are more reactive than copper. So that's why these elements replace the copper. Understand? So what is displacement reaction? Or displacement reaction is a chemical reaction in which one element replace another element. And which element replace? Most reactive element replace least reactive element. So you have to learn this whole reactivity series. Okay, then you are easily able to solve all the reaction of displacement reaction. How you learn? There are some tricks. From that you easily learn the reactivity series. You didn't have to rectification method to learn this reactivity series. What was the method? See here. Please stop calling me a careless zebra. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. This is one sentence. If you learn this sentence properly, then you are able to learn whole reactive series easily. How? See here. In please, P represent potassium. Stop, S represent sodium. Calling, Cl represent calcium. M, in me M represent magnesium. A represent aluminium. Car represent carbon. Z represent zinc. I represent iron. T represent T is not representing anything. L represent lead. H represent hydrogen. C represent copper was full written here. S represent silver and G represent gold. Okay, T is not representing anything. Okay, I, then L. Okay, so you have to learn whole sentence, then you are easily available to learn all the reactivity series element with a proper reactivity, means from most to least reactive metals name. But you have to only remember that you know the full form of P, S, Cl, M, then you are able to learn. If you didn't know which symbols is represented which symbol, if you didn't know P represent potassium, but in element in periodic table potassium is represented by K, but for learning we are taken P. Okay, so this is completed.